So as I've mentioned, our exam in the lab will be practical. So it will be uh, with the demonstration or the use of equipment and familiarity of procedure. Okay? So una sa lahat, syempre, yung parts of the microscope. So you must know which ones are the low objective lens and which ones are the high objective lens. Okay? So we will use the monocular para walang ano, para uniform lahat, no? So you have the ocular lens, syempre, this the part. We're recording already. Okay. So the ocular lens is of course this one. So another term for that is the eyepiece. So for the, of course, there are binocular lenses. You have two uh, eyepieces. So this is the lens that you look through to view the specimen. So there is still a lens in the eyepiece that will magnify the that will add to the magnification to the of the specimen. Okay, so it's a not add multiplying effect. Okay, so of course you have the coarse adjustment knob. So it depends on the microscope, but for the monocular microscope, the coarse adjustment knob is on that side. Okay, so we already saw the monocular compound microscope. So the coarse adjustment is used for you can use that you can I mean you can freely use that when you're using the low objective lens. But when you're using the high objective lens, there's a danger you might break. Okay. So what you can do is you can put the high objective lens as close as possible dun sa coarse adjustment knob. Tapos patras nyo na lang yung. And then you have the fine adjustment knob, which is this one. So this knob is used to bring the image of the specimen into a sharp focus after the coarse adjustment knob has been used. Okay? So one way to check kung talagang slide yung nakikita nyo, no? So galaw-galawin nyo yung slide. So pag wala kayong nakikita movement, ibig sabihin hindi pa yung nakafocus, no? So medyo i-move nyo yung slide, ibig sabihin malapit na yung focus nyo doon. Kung ginagalaw nyo yung slide, wala kayong nakikita, walang movement, ibig sabihin iba yung focus nyo. Okay? So that's one way to check kung uh, yung mismong slide yung nakikita nyo. So remember to bring yung surgical gloves dun sa exam. Okay? First, of course, you have the stage clips. So this supports the microscope slide. So meron siyang central opening for the entry of the light. And then these are the revolving nose pieces. So you can rotate and change the objective lens that you need. So these lenses magnify the specimen. So yung low objective lens, yung medyo shorter uh, yung haba. So that's the low objective lens. Usually 4 times. So 4 times dito sa low objective. Tapos yung sa eyepiece mo usually 10 times. So 4 times 10 will be 40 times. Okay? So depende yun sa microscope. Nakalagay naman yun sa mismo objective lens. And then you have the higher objective lens there, medium, and then the high power. And then you have the diaphragm. So it's baba nito. You have the diaphragm, which controls the amount of light that reaches the specimen. So for our compound microscope, we have the mirror, no? Pero mas effective kasi yung ilaw sa cellphone, kaya pinapagamit ko mas bright. Kaya, at saka yung ibang microscope, sila may light sources. So parang ano natin, improvise natin. Matagal na kasi yan. So I think I need to request na repair yung mga microscope. Kasi ngayon lang nag-face to face kaya hindi pa, so siguro by the end of the sem we will fix those microscopes. Okay? So this is one of the parts of the practicals. So we have may mga 5 hours naman tayo. So I can have time. I do have time to ask for. Okay. So another topic that we just discussed the gram staining. Pero um, again, since we're adjusting to face and some stains are not available, so I cannot. We'll try to do it for the finals. Kasi may mga lacking mga equipment. So we'll see what we can do about this staining. But for theoretical use, you need to know also. So that's why I'm going to discuss it also. So this is part of your second PowerPoint. So this is the staining microscopic specimens. So there's limitation if you use the light microscope. No? So uh, the organisms are translucent, so you cannot see clearly the parts of the specimen. And before you do that, you need to place the specimen on the slide. Okay, so you call that mounts. So there are two basic types of preparation to view specimens. You have the wet mount and the fixed specimen. We did try the dry mount, but it's problem with the dry mount. Medyo mahangin yung room. So, at saka hindi for all specimens. No? Kasi you can only use that for specimens like yung wing ng insect or plant leaf. So those are specimens you can use the dry mount. But usually we use the wet mount if we want to see specimens, especially if you want them seen live. Okay, so this is the simplest type of preparation is the wet mount. So the specimen is placed on the slide in a drop of liquid. And then once the liquid has been added to the slide, the cover slip is placed on top, and the specimen is ready for examination under the microscope. So in viewing this specimen, no, sometimes we need them na-fix. Siyempre, kung gumagalaw yan, we need to look at the parts of the specimen. Gusto natin na-steady lang. No? So the second method of preparing specimens is through fixation. Okay, so we're attaching the cells to the slide para hindi na gumalaw. So there are two types of fixation. One way is through heat. So pwede mong padaanin yan several times dun sa flame para yung proteins ng organism mag-coagulate. Okay, so mag-denature yan, mag-coagulate. Pero ang disadvantage yun, syempre, you can, dahil denature yung protein, hindi na-accurate yung size, yung, if you want to know the actual size, heat fixing will not be that accurate. Kasi dinedenature mo nga yung mga proteins. So, tsaka nag-expand. So, that might not be accurate. So, the better way is to chemically treat the specimen. So, the additional advantage of fixation, if it kills the microorganism in the specimen and stops their movement. So, you can view the cell, you can view the organism with its cell components. Okay, so to heat fix a sample, so you're going to spread a thin layer ng specimen. So liquid yan, we call that a smear. So you spread it on the slide and heat it briefly, not for long. No, you don't want the water to boil. So just pass it over a heat source around 3 times. So until medyo mag-dry tapos yung proteins ay mag-coagulate. So again, the disadvantage of this method is it will not be accurate in the size, and it may destroy the 3D structure of the object. So usually we prefer chemical fixatives. So in addition to fixation, staining is almost you're going. It's better to apply staining so that you can see the features of the specimen. No? So yung ginawa natin sa ayog sepa, sa onion. So nilagyan natin ng dye, and because we use the dye, nakita natin yung cell wall and then the nucleus. Okay? So that's the advantage of using staining. So stains or dyes contain salts made of the positive ion and the negative ion. Okay, so here you can see the structure of crystal violet. So sa chemistry, may tinatawag tayong chromophore. So yung chromophore, it just means a colored substance, no? Colored chemical. So because of the not all ions or not all organic compounds are visible may color na distinct, no? Pero due to certain parts of the structure, like the double bonds and like the presence of certain ions, nagkakaroon ng color. So we call that chromophore. From the word chromo, which is color. Okay? So yung mga cells, they have typically negatively charged cell walls. So ginagamit dito yung basic dye. Okay? So mga basic dye like crystal violet, fuchsin, malachite green, methylene blue, saffron. So these are used as positive stain. Okay? So positive stain or a basic dye. Okay, dito naman, you'll see a structure on the right side. That is a structure of eosine. Okay? So kita mo meron kang C double bond O minus. Okay? That's a carboxylate group. So if the negative ion is the chromophore, so this is acidic dye. So digen, so this structure is acidic. So when you're using an acidic dye, you create negative stains. So ang mangyayari, kasi negatively charged ang cell walls ng bacteria or plant cells. So this gives them negative stain. So kumbaga background yung nagkakulay, tapos yung cell walls hindi nag-absorb. So we have the commonly used acidic dyes, fuchsin, acid fuchsin, to differentiate that from fuchsin basic, eosin, and rose bengal. Okay, so dyes are selected for staining based on the chemical properties of the dye. So depende, you need to look at the properties of the organism, kung bacteria siya, kung uh, usually since you have the negatively charged cell walls, so depende kung anong gusto mo tingnan sa substance. Okay? So most of the time, we use the positive stain. So gusto mo ma-observe ng organism mismo yung stain. So you can see the colors kasi na-absorb ng cell walls or na-absorb ng nucleus. So you can be able to see the different parts of the organism. But there are cases na mas gusto mo negative stain, no? So ayaw mo mag-absorb yung organism, no? So you want to see, for example, yung size ng organism. Kung negative stain, hindi affected yung mismo na-preserve mo yung integrity ng structure ng specimen. So if you want to know the exact size, use negative stain. Kasi background yung may kulay, tapos di na-absorb ng mismo organism. So negative staining produces an outline or silhouette of the organisms against a colorful background. Okay? So ito, example, you have the Bacillus anthracis. So, kita mo dyan sa left na picture, in-observe siya ng crystal violet. So, that's a positive stain. So, sa gitnang picture, so this is an example of a positive acidic stain. Okay? So, ginamit yan ay rose bengal sa Spinaloricus. Dun sa last picture, on the right side, so ginamit dito negative staining. Kumbaga yung background mo yung kulay. So you have the negative red staining applied to the slide. So your cell doesn't absorb the dye itself. But you can see the outline and you can get the exact size of the organism. So, yun, depende sa anong reason mo to observe yung organism. So, you use different techniques. There are two types of staining. Maybe wait a minute. Okay, so sorry about that. Let's go back to this one. Okay, so you have two types of staining. So you have the simple staining. You're going to use a single dye, and through that dye you can see the different structures of the specimen. Okay, and then there is the differential staining, which you use multiple stain in order to distinguish organisms. So we're going to discuss this different staining. So of course you're familiar with the gram stain procedure. This is part of your lecture still because we need that to distinguish between gram positive and gram negative bacteria. Okay, but this is the most popular one. So it's an effective method to distinguish different bacteria. So this is discovered by Hans Christian Graham. So you basically add iodine with crystal. So if you have crystal violet, and then you have an added iodine, and because there's a for gram positive, there's a thick layer of of peptidoglycan, so it's able to absorb with the help of the iodine. The crystal violet is absorbed well in the thick layer of the peptidoglycan. Okay, so when you add a decolorizing agent for the gram positive, hindi yan nawawala yung kulay. So they remain purple. So because the gram negative bacteria, they have thinner peptidoglycan, so mas natatanggal. So you add alcohol and you immediately wash away the crystal violet. So this will make them colorless. Okay. Let's just rejoin again, guys. So I will stop this and then just join the next session.